Everyone, welcome to the discussions of the past year questions. This video we shall discuss further mathematics paper 2, May-June 2024, paper 23. Let's take a look at the first question. Find the exact value of the integrations over here. Okay, so for these questions, you can see that this is a quadratic. So what you need to do here is we have three terms over here. So we try to complete the square. So first of all, the denominator looks a bit troublesome. So we try to make it like this. X minus 2 square, then minus with 3. So expand, you get this. So first of all, I do complete the square first. Then now we can start to integrate. 7 over 2, 1 over the square root of 4x minus the x squared minus 1 dx is actually the same as the quadratic that you have completed the square just now. Okay, so with these situations, with this form, you can refer to the formula booklet. Just refer to the formula booklet FF19. We have the integrate of square root of a square minus the x square dx. The answer will be the arcsine of x over a. Okay, so we will be using this formula from the formula booklet MF19. This one, I erase it. Okay, so using the formula booklet directly, we can integrate this as arcsine of x minus 2 over 3. Then just put in the value 2 until 7 over 2. Substitute in, you get this as the 3 over 2. 3 over 2 so 3 minus the arcsine of 0. So this one, just press a calculator. You can get the answer in terms of radian. It will be pi over 3. Just like that, done. This will be the answer for the question number 1. So now we're moving on to the question number 2. Okay, now we look at the question number 2. The curve C has the parametric equations as given: x equal to cos t and y equal to sin t for the t between 0 to 3 over 5. And they want you to find the arc length of the C. And then they say that this arc length is denoted by the symbol of S. So first of all, we need to know the formula. To find the arc length, we need to find the dx dt. Dx dt will be sin t. Then dy dt, it will be cos t. Okay, so the formula for S is integrate from 0 to 3 over 5. It will be square root of the dx dt square plus the dy dt square. This is the formula. And if you substitute them inside here, you will get this one as the sin square plus the cos square. Okay, sin square plus cos square is according to the hyperbolic identity. One should know that this one is supposed to be cos 2t. Okay. So, shown. Okay, this is how you show the expressions that the arc length of a curve C can be represented as such a form. Okay, done. Now we move on to the B. They want you to find the Maclaurin series for this up to the terms in t square. Okay, so we first of all, we let ft equal to the cos 2t. I prefer to write it as a power half. Then I differentiate it for the first time. It will be half cos 2t power negative half, and then 2 sine 2t. This one will give you cos 2t power negative half and sine 2t. Okay. Then after that, we need to differentiate for the second time because we need to do until t squared. So I need to do until second derivative. Keep the left, differentiate the right. Plus keep the right. This one a bit long. I need to write it below here. Plus you keep the right and differentiate the left. Okay. Well, still not enough place. Let me try to squeeze everything inside. Here, this one will be 2 sine 2t. Okay. Now I don't plan to simplify this anymore because I just need to find out what is the f0, f prime 0, and f double prime of 0. So if I put f0 inside the first one here, I will get this one as the 1. Okay, directly. Then if I put 0 inside here, f prime 0, you can see that the sine 0 is a 0. So this one will be a 0. Then the last part, the second prime, over here, if I put 0 inside, I get a 2. And then if I put a 0 inside here, I get a 0. So this f second prime is a 2. F second prime of 0 is a 2. Okay. So therefore, your ft, okay, your square root of cos 2t is approximately, okay, maybe we just say equal first. I don't want to use approximation sign. So it will be 1 plus the 0t plus the 2t squared over 2 factorial plus a dot, dot, dot. Okay, that means there's the term continue, okay, but we just need to show until t squared. So this one, it will be the same as, it will be approximately same as 1 plus the t squared. Okay, so now we come to the integration part. So your x equals to this, 3 over 5. Back to the question part A. Then it will be approximately equals to integrate 0 to 3 over 5, 1 plus t squared et. Because I have used the Maclaurin series to approximate them. Then this one t plus t cubed over 3. I do not need to use approximation sign anymore. Just use equal sign will do because I already used the approximation sign over here already. So there's no need for me to use the approximation sign anymore. So it's 0 to 3 over 5. Substitute 3 over 5 and 3 over 5 cubed over 3 minus a 0. Okay, so if you press the calculator, you will get the answer as 84 over the 125. Okay, no square. Okay, so this is the answer for the question number 2. Okay, then move on. We have question number 3. Okay, now we take a look at question number 3. The curve C has the equations of x cubed plus 2xy plus 8y cubed equal to negative 12. show that at the point of -2, -1 on C, the dy dx is a -half. So we have implicit differentiations over here. This one not so difficult. Just differentiate directly. 3x squared plus this one, keep the left, differentiate the right, plus keep the right, differentiate the left. This one is a 24y squared dy dx equals 0. We join the dy dx together first. Then plus the 3x squared plus the 2y equal to 0. So at the point of -2, -1, so you have a -4 plus the 24 dy dx plus the 12 minus the 2 equal to 0. So your dy dx equals to the -10 over 20 equal to -half shown. Okay, so this part is quite straightforward. Now we want to do the B. Part B is they asking you to find the d square y dx square, the second derivative at the same point as well. So the second derivative, I will differentiate from here. It will be easier. So differentiate. Let me just copy down. Easier. No need for me to refer up and down. So this one is a 2x plus the 24y squared dy dx from the part A. This is the result that we have, 3x squared plus the 2y. Okay, so now from here we derive again, keep the left, differentiate the right, plus keep the right, differentiate the left. Plus the 6x plus the 2 dy dx equal to 0. Okay, so over here, well, we can try to simplify them, but I don't think I want to make it so to simplify them again. Okay, but can maybe we can simplify it. So if we simplify it, we have a 4 dy dx here plus the 48y dy dx square plus the 6x equal to 0. Now we just substitute at the point -1 and -2. My dy dx is a -half. So you have this as the -4 plus 24 of the d square y ds square plus the 4 -half minus the 48 of the -half square minus the 12 equal to 0. So you just simplify it. You have a 20 d square y dx square equals to 12 -24 -24. And 2, yeah, 26. So you have a d square y dx square is equal to 26 divided by 20 is 13 divided 10. Okay, done. So this will be the answer for the question number 3B. And moving on. So now we are going for the question number 4. Okay, now we take a look at question number 4. We have a diagram here shows a curve with the equations of y equal to x power -2, where the x is from 0 to n, together with a set of n minus 2 rectangles with a unit width. So unit width means the length over here is 1 unit. 1 unit, okay, yeah, it's 1 unit. So this is called the unit width. Now, they asking us to considering the sum of the area of the rectangle, show that this inequality is true. So how are we going to show it? Over here, if they give you this, that means this one is the area of rectangle. This one is the integrations area under the graph. Okay, so what you need to do here is, first of all, you just need to show, in order for the area of rectangle to be bigger than the area under the graph, so your rectangle that you build must be higher than the graph. Okay, must be higher than the graph, like this. Okay, until here. Okay, so we start from the first rectangle. It will be, okay, first of all, I let this call fx. I let the function, I let the graph, function of the graph call fx. So my f2 multiply 1 plus the f3 multiply 1 plus until fn minus 1 multiply 1 is greater than the area under the graph. You integrate from 0 to n of x power negative 2 dx. Okay, so this is what you need to do at first. So over here, you can summarize them as a sum of r from 2 until n minus 1 of fr is greater than, you integrate it, you will get negative x power negative 1, 2 to n. Okay. Now, the answer over here is in terms of fractions, and this series or the sigma over here, the r must start from 1 and until n. Okay, so what you need to do is to make this r equal to 2. This is the 1 over the r square, n minus 1. Okay, first of all, I write like this first. Negative 1 over n plus the half. Okay, so this is what I have. But in order to make this r equal to 2 and n minus 1 to become r from 1 until n, what I need to do is I need to add 1 over 1 square inside. And over here, I need to add 1 over n square inside. But when you add these two terms inside here, your right hand side also add the same term. Okay, also add the same term. So exactly adding the same term, so that they are still remain, the inequality still remain. Okay, so for your left hand side, after you add two terms over here, your left hand side, this whole thing, you can summarize them as the sigma of r from 1 until n. So this one, you simplify it. Your right hand side, if you simplify it, you get 3 over 2 minus the 1 over n plus the 1 over n square shown. Okay, so this is how you show the result. Okay, so that is the answer for the part A. Now we move on to the part B. They want you to use a similar method to find the upper bound for this one. Okay, so upper bound, that means they want to find that this series is less than the upper bound. Okay, and we want to find the upper bound. So now this time they want the area of rectangle to be lower than the area under the graph. So in order to get the area of the rectangle lower than the graph, that means the rectangle that you draw over here, it must be shorter, must be like that. So you must use this rectangle. Okay, at the end is you're using this rectangle. Okay, so again, I still let fx equals to negative x, x power negative 2. Okay, so but I need to start from the f3. Multiply 1 plus the f4 multiply 1 plus a dot 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 plus until fn multiply 1 is actually less than the integrations of 2 until n of x power negative 2 dx. So over here, my left-hand side, I can summarize them as 3 until n of fr less than this one. Just copy from the answer here. Just copy from this part, negative 1 over n plus half. Okay, so in order to get the series start from 1, okay, so you over here, we just need to, this one I change it to become 1 over r square less than negative this plus this. So over here, I need to plus 1 over 1 square plus 1 over 2 square. I need to add these two terms. So when you add 1 over 1 square plus 1 over 2 square, over here, I also need to add 1 over 1 square plus 1 over 2 square. So if you add together now your left hand, you can combine them together, become the series that start from r equal to 1 until n. So this one is the half 7 over 4 minus a 1 over n. Okay, so that will be your upper boundary. This will be your upper boundary, just like that for the part B. Okay, so now we're moving on. C, we want to find the lower and the upper bound of this when the n goes to infinity. Okay, that means when the n go to infinity. So first of all, we just need to write like this. Combine the result from A and B. The result from B is this. The result from A is 3 over 2 minus 1 over n plus this. Okay, so you just need to put the limit of n approaching to infinity of this. Okay, I think no need to be so troublesome because the question gives you 2 marks only. We don't need to show so many things over here. We just need to mention that when the n is approaching to infinity, so you will get 3 over 2. This one is infinity, 1 over r square, and 7 over 4. Just like that. Done. This will be the answer for the questions number 4C. Okay, so now moving on, we have question number 5. We take a look at question number 5. Find the general solutions of the differential equations as given here. So for this question is a second order differential equations. First of all, we just need to take the left-hand side out. Let's take the left-hand side out. D square x dt square plus the 10 dx dt plus the 25x. Let it equal to 0. Then from here, we will form the auxiliary equations, AE. Then you get m squared plus 10m plus 25 equal to 0. And if you factorize it, you get a repeating factor. So your m is a negative 5 and a negative 5. So from here, your complementary solution over here is x. It will be equal to the ae power negative 5t plus the bt of e power negative 5t. You can also factorize it out, leaving it as form. So this will be your contemporary solutions. Then now we want to go for the particular integrals. To find the particular integrals, we look at the right hand side. This is a trigo, so we just need to let our xp as the general form for the trigo will be P cos t plus the Q sin t. So we need to differentiate this for 2 times until the second order. You will get negative P sin t plus the Q cos t and negative P cos t minus a Q sin t. And then substitute them back into the original equations. You have a xp double prime plus the 10xp prime plus the 25xp will be equivalent to the 338 sine t. Okay, so we need to put everything inside carefully. So it's a plus a 10 of the negative b sine t plus a q cos t plus the 25 of the b cos t plus the q sine t is equal to the 338 sine t. Group them together. All the cos you join together, if you join together, you get 24p plus 10q cos t. And then all the sine, if you join together, you get 24q minus a 10p equal to the 338 sine t. By comparison, (24p plus 10q equal to 0). That will give you the q is equal to the negative 5 over 12p. I call this one equation number 1. Then another one to compare is the sine. You have a 24q minus a 10p is equal to the 338. I call this one 2. 1 into 2. That is, you get 24 over negative 5 over 12p minus a 10p is equal to the 338. So 338. Then you get this calculation. Your p, it will be a negative 5. Oh, sorry, I make a mistake. This is a negative 12 over 5. So this is a negative 12 over 5. So if you press a calculator, you get the p as a negative 5. Okay. Then after that, you can get the q as a negative 12, as a positive 12. So therefore, you have found x equal to the xc plus xp. Then you can get this xc as the a plus the bt e power negative 5t minus the 5 cos t plus the 12 sine t. So this will be the answer for the question number 5A. Okay, just like that, done. Now we move on to the question B. Show that for the large positive values of t, for any initial conditions, the x will be approximately equals to the r sine t minus alpha, where the r and the phi are not alpha, is phi, r sine t minus phi, where the constant r and phi are to be determined. So what you need to do is that when they mention the large values of t, so that means when the t is approaching to infinity, when it's the t is approaching to infinity, so your this value will become 0. You're approaching to 0. Then you're left with only these two. That is the meaning of it. Okay, so just mention, then your e power negative 5t will be approaching 0. Okay, so that means your x will be approximately equals to negative 5 cos t plus the 12 sine t. Okay, then over here we need to show this. Given x is approximately equal to this, so it will be the same as a r sine t cos phi minus the r cos t sine phi. Okay, so by comparison, your r cos phi, you compare these two, your r cos phi will be a 12. Your r sine phi will be a 5 by comparison. Okay, so now what you need to do is to find the r square. Just take the 12 square plus the 5 square. Then it will give you r is equal to 13. Then your tangent phi is equal to the 5 over 12. From here, you can find your phi in terms of radian. It will be 0.395. Okay, done. This will be your answer for the phi and r. Okay, so basically, therefore, your x is approximately equal to the 13 sine t minus a 5. 3 significant figure. Done. Just like that. That is the answer for the question number 5b. And moving on, we have a number 6. Now we take a look at question number 6. Show that the series z to the power of 4n for r equal to 1 until n is equivalent to this expression where the z square not equal to z to the power of negative 2. So what you need to do is at first, I just write down the left-hand side, and I list them out one by one. It will be z to the power 4 plus z to the power 8 plus until z to the power of 4n. So you can see that this is a GP where the A is equals to the z power 4 and the common ratio is also z to the power 4. So therefore, the series of z 4 to the power r, z to the power of 4r is equals to the A of r power n minus 1 divided by r minus 1. Just use the GP formula. So what you can do here is that we factorize the z square out. And here got z square, z power 4n minus the z square. Then over here, you factorize the z square out for the denominator. You will get this one as a z square minus the z to the power of negative. Cancel the z square, and you can see that you will have z to the power of 4n plus 2 minus the z square divided by this z square over z to the power of negative 2 shown. Okay, so this is how you show the 6th part A. Now we want to go for the part B. Okay, use the result that you have over here, this result, just apply them over here. But this time you need to let the z equals to the cos theta plus I sine theta. So we let our z equal to the cos theta plus I sine theta. So you need to understand that z square will equal to the cos theta plus I sine theta square. You will get this as a cos 2 theta plus the I sine 2 theta. Then your z power negative 2 will be cos 2 theta minus the I sine 2 theta. I'm applying the de Moivre theorem actually. So I need to get this one ready first. Then I can get z squared minus the z to the power of negative 2. Add together, minus together, you will get 2i sine 2 theta. Okay, so this is what I need in order to solve the problem. So now the question is based on the part A. From A, we already have the result of this. And now I change the z directly to become cos theta plus I sine theta. So this one, it will be cos theta plus I sine theta power of 4n plus 2 minus the cos theta minus the cos theta plus I sine theta square. Divided by the 2i sine theta sine 2 theta. Okay, so this is what I have. So by using the de Moivre theorem, okay, by using the de Moivre theorem, I will have my left hand side as the cos 4r theta plus I sine 4r theta, okay, equals to the my left hand side. My right hand side will be cos of 4n plus 2 theta plus I sine 4n plus 2 theta minus the cos 2 theta minus the I sine 2 theta. Divided by 2i sine 2 theta. Okay. So for this case, there is a imaginary number here. There's an I here. So we want to make the I disappear. I just need to multiply I for both of it. So this time, if I multiply I, then I will get this one as I cos 4n plus 2 theta minus a sine of the 4n plus 2 theta minus I cos 2 theta plus the sine 2 theta. If I multiply I for the numerator and the denominator, then my denominator, if I multiply I get negative 2 sine 2 theta. Okay, so this is what we have. Then after that, we just compare by considering the imaginary part. Okay, why do I need to consider the imaginary part? Is because the imaginary part, it will contain sine 4r theta, and the question is looking for the sine 4r theta. So that's why we need to use the imaginary part to compare. So by comparing the imaginary part, you can just only consider the left-hand side, just write down the sine 4r theta. No need to put the I because you already considering the imaginary part. So the I can be ignored. Okay. So now for this right-hand side over here, you also just need to consider the imaginary part. Again, just group them together. Those with the I, group them together. Then you can just ignore the I. So this will be cos 4n plus 2 theta minus the cos 2 theta divided by the negative 2 sine 2 theta. So we have a negative here. So we try to make the negative disappear by multiply negative on the numerator and the denominator. Then you will get this. Okay, so is this the answer that they want you to show? Yes, correct. This is what they want you to show. So not done. So therefore, this will be the answer for the question number 6 B. Now we're moving on. Go to the question number 7. Okay, now we take a look at question number 7. A. Show that differentiate this will equal to this. So what you need to do, just need to differentiate directly. Tricky things over here. Just direct differentiate. So this one is you keep the left, differentiate the right. So you keep the right and you differentiate the left. This one is 9 over 2. Our cos of x over 3. Just check the formula booklet, MF19, then you will get this. Okay. Now the thing is that we need to simplify them carefully. So you can get this one as the x squared over 2 square root of x squared minus 9 plus the square root of x squared minus 9 over 2, then minus the square over 9. So you get a 9 over 2 square root of x squared over 9. Like this. Okay. Then we just need to make sure the denominator all same. And then join together. So at the end, you get this one as the x squared minus 9 over the square root of x squared minus 9. Therefore, you get this shown. That is the answer for the number 7A. 7B, asking you to solve the first order differential equations of this one. Given that y equal to 1, x equal to, when x equal to 3, and they want your answer in terms of y in terms of x. So what you need to do here is that these questions, you need to decide it belong to which method. So this one is a linear equations. It's supposed to be using the linear factor, the IF, integrating factor. I divide everyone by x. I get this. Then my IF is e to the power of integrate negative 1 over x dx. It will be e to the power of negative ln x. It will be e to the power of ln 1 over x. It will be 1 over x. Then you multiply everyone by the IF. You get this. So take the IF and the y multiply together. it will be the same as you integrate the right-hand side. Because from part A, we already show that differentiate this whole thing will give you this. That means integrate this will give you back the original one. Okay, so we just apply from the part A. Just say that from A. So this one, it will be x over 2 square root of x squared minus 9 minus the 9 over 2 cos of x over 3. Remember to put a plus c. Now our job is to find the c. Given when x equal to 3, y equal to 1. So you have a 1 over 3 equal to the 3 over 2, 0, minus a 9 over 2, a cos of 1 plus the c. So from here, a cos of 1. So this one is a c is a 1 over 3. Because a cos, this one a cos of 1 is a 0. A cos of 1 is a 0. So the c is 1 over 3. So therefore, your y, I straight away multiply the x go to the right hand side. Straight away multiply x go to the right hand side. So therefore, my y, it will be equals to the half x square square root of x squared minus 9 minus a 9 over 2x, a cos of x over 3 plus the 1 over 3x. Just like that, done. This is the answer for the number 7B. And moving on, question number 8. Okay, now we take a look at question number 8. The planes pi 1 and pi 2 do not intersect and are both perpendicular to the I plus 2j plus 3k. The line L intersect L1 at the point 160 and intersect pi 2 at the point 3 negative 60. Find the Cartesian equations of the pi 1 and pi 2. Okay. So what we can do is that they say that the pi 1 and pi 2 both perpendicular. That means this one is a normal vector. So we need to use back our AS knowledge. We need to use back our AS knowledge on the equation of plane. So the normal vector can help you to form the equations of pi 1 and pi 2 already. So for equations of pi 1, it will be just like this. Your normal vector is 1, 2, 3. This one is also 1, 2, 3. Your value here is x, y, z. It's a random point. Then the point on pi 1 is a 160, as given in the questions. You will get this as the answer. 1 plus 12, 13. Then your equations of pi 2 also same. One, two, three here. 1, 2, 3 here. This is the x, y, z. Another one is a 3, negative 60. So at the end, your equations of plane pi 2 will be this. Done for the question number 8A. Moving on, B. Express the equations of line L in the form of this, where the A and B are the vector to be determined. Hence, show that the half x plus 1 over 12y equal to 1 and z equal to 0. Okay, equations of line L. Line L is according to the descriptions. Okay, line L pass through these 2 points. So first of all, we just call the point OA as 160, then the OB as a 3, -6, 0. So we're going to form the AB, the directional vector of the line L. So this one AB will be the 2, -12, and 0. Okay, so your equations of line R will be equals to the, I choose the point A plus the lambda of the B. This one, the vector B is the directional vector. 2, 2, -12, 0. Actually, we can take the 2 out, make it become more simplified. That will be better. So I will make it become 1, -6, 0. Like that. That will be easier. Okay. So now they asking you to show that the points on L. Okay. So over here, if you combine together, that will be your x, y, z. Okay. So by comparison, x equals to the 1 plus lambda. Y equal to the 6 minus 6 lambda. And the z is equal to 0. Okay. So our lambda is equal to x minus 1. I call this one equation 1. I call this one equation 2. 1 into 2, I get y equal to the 6 minus the 6 of x minus 1. Then you get this one as the 6 minus the 6x plus a 6. Then you get a 6x plus y is equal to 12. Therefore, you are having 1 over 2x plus the 1 over 2, 12y is equal to 1. Shown. Okay, together with a z equal to 0. So this is the answer for the question B. And now we move on. C. The matrix A is given as such, so that the characteristic equations look like this, and hence find the eigenvalues of the matrix A. So we need to find the eigen value by forming the characteristic equation first. So the characteristic equation, first of all, you need to have the formula. That means it will be 1 minus lambda one 2 minus lambda and minus lambda. Okay, so here you will get this negative lambda 2 minus lambda minus a 1 over 4 minus a 2 negative lambda minus 3 over 2 12 minus a 1 plus the half lambda equal to 0. So this one you need to expand carefully. 1 minus lambda square minus the 2 lambda minus the 1 over 4 plus the 2 lambda plus the 3 minus the 11 over 4 plus the 3 over 2 lambda. Okay. So we try to simplify it. Okay, you get the lambda square minus a 2 lambda minus a 1 over 4 minus a lambda cube plus the 2 lambda square plus the 1 over 4 lambda. Then this one joined together, you have hey, I make a mistake. This is a negative lambda cube. Then you join together, you get 7 over 2 lambda, then 1 over 4. Positive. So this one can cancel off. Again, you get negative lambda cube. For the lambda square, you have a 3 lambda square. Then for the lambda, have a minus 8. 14, 15 minus 8, 7 plus a 7 over 4 lambda. Yeah, shown. Then to find the eigenvalue, we just need to take the 4 out, take the negative 4 out, lambda, make it become lambda square. This one become 4 minus the 12 lambda minus a 7. Then you try to factorize it. Seven. Hey, sorry. This one is a 1. So therefore, your lambda eigenvalue, lambda equal to 0, lambda equal to negative half, and your lambda is equal to 7 over 2. These are all the eigenvalues. Done. Okay, for the part A. Part C. Now we want to go for the B. We want to find the matrix B and the diagonal matrix such that it will follow the relationship A power n equal to the BDP inverse. So to find the B, we need to find the eigenvector. So when the lambda equal to 0, just change all the lambda here. Just replace this lambda equal to 0 inside. If you put lambda equal to 0 inside, we can take the, we will having this 1, 2, 3, 1, 2, 3, and so we will take these two. We will take these two to find the cross product so that we can find the eigenvector. So move on. When the lambda equal to 0, I will take this. Get 1, 2, 3. And half 1 over 12, 0. Do the cross product. I get negative 1 over 4i plus 3 over 2j minus 11 over 12k. Factorize the common factor out. I want to make the vector integer. So this one is a 3. Negative 18 and 11. Okay, so this is the lambda one. My E1 is 3, 18, negative 18 and 11. So when the lambda number 2, I choose 7 over 2. Again, you repeat the same process like the lambda number 1 just now. We substitute in and choose the one that we can multiple cross them. So I will choose and get this. This one is 1 minus 3 over 2. The first two row, I choose the first two row. Do the cross product, 21 over 2i plus the 21 over 2j plus the 7 over 4k. Factorize the common factor out. Then I get this one as a 661. So therefore, this is a E2, 661. Then when lambda number 3 is equals to the negative half, repeat the same process again. Nothing special anymore. Also take the first two rows, and I get this. Okay. So I factorize the negative 1 over 4 out. I get a 6, 6, and negative 7. Okay, so that it will be my E3. So therefore, my P will be the E1. E1 just now is 3, negative 18, 11. E2 is a 6, 6, 1. E3 is a 6, 6, negative 7. So this will be my matrix P. Okay, my matrix P. And I need to find the matrix diagonal. Okay. The information given is A power n is equal to the PDP inverse. Okay, so the D is actually the diagonal power n. Okay, the diagonal matrix is 0, 0, 0, 0. Lambda 1, just now lambda 1 is 0. Lambda 2 is a 7 over 2. This is a negative half. So at the end, your answer will be like this. 7 over 2 power n, negative half power n. That will be your D. Okay, that will be the answer for the question number 8. And done. Okay, so we have completed this paper. I'll stop the video and I'll see you next time. Bye-bye.